Hi there, in this video I'd like to discuss switch debounce. This is a situation where a switch can flicker between on and off for a few moments after it's been pressed. The reason for this is that a switch is basically a spring and a set of contacts, neither of which are perfect, and to explain further I have a diagram behind me here which we'll just switch to now. So when a switch is pressed, there's a spring inside the switch. Along with the spring there's also contacts. Neither of these are perfect. So what tends to happen, like any spring, when we push on the spring we basically force the spring to contract, and the spring will naturally try and react by bouncing back to its original state or even beyond it. And this situation is known as bounce. And when we combine that with the fact that contacts aren't perfect, when we first make a contact, there's every possibility that it will bounce like this, where the contact goes between on and off. Obviously, if we're trying to do something where we latch in software, that's not a good thing to happen. So if we examine this more closely, what we see is that bounce actually is a function of time. So what happens is, let's say we press the switch here, yeah, so we'll call that point P, and before that the switch is permanently off. At this point we press the switch, it goes to on, it goes back to off, it goes to on again, it goes back to off, and then it goes to on. This is a fairly unusual example. This isn't what it would probably look like if you looked at it on an oscilloscope, but this is just for the purpose of example, so that we can demonstrate how to write software to manage this. So there's two ways we can do it. The first way is we can just put a delay in the software, and it's much less likely that we'll see bounce just by having a delay, where we only check the switch every 10 milliseconds. But let's say, but even then we could get the switch in the wrong state and it could go between on and off. There's only one way to do it properly, and that's to write software that checks multiple times and actually maybe even ignores the first change if there's a temporary change in the switch while we measure. So in order to understand what debounce is, we first have to write a little bit of software on the Arduino, which we'll see next. You can also take a copy of that from my website. The link is in this video. And in addition to that we'll need the simplest circuit for the Arduino we can possibly build, and that will be, here's our pin, here's 5 volts, and here's ground, and we are literally going to take a switch and a resistor. We're going to connect them up like this. There we go. So a resistor between 5 volts and the switch. The Arduino is connected to that side of the switch, and the other side of the switch is connected to ground. On the flowchart, it's just about the simplest version of switch debouncing software that you can write. This just gives you an idea. I'm not saying that this is the pinnacle of debouncing a switch, but this will give you an idea of where to start writing one. So what we do is we get the switch's current state and we check if that state is the same as the last reading. If it isn't, we change the last reading and we wait a bit. Basically loop round and get the switch state again, and then we check if it's the same as the last reading. So let's say it's bounced again, then we change the last state and we wait a bit, And we keep doing that until we get into a stable state where this can go through because we've had 2 readings with the same state. So at this point, once we've got here, we record the new reading. So it's only here that we would actually record the fact that the switch state has now changed. So if it had bounced several times in the meantime, that wouldn't be recorded. Now there's a few caveats for this. Obviously this wait a bit is very important because that must be in about the same region as the bounce of your switch, or even a greater delay than the bounce of your switch, so that you know for sure that once you've gone through a couple of loops of this, the switch debounce would definitely be over. But as long as that were true, this is the simplest way to actually debounce a switch.